top two questions required you to solve proportions as well. But when I just gave you guys a straight up proportion like we did here, just a skill based question, some of you lost your dang minds. All right, like I said, there's that small 5 to 10% of you kind of screwed up here, and then there's more of you that might have screwed up on this one. But if I gave you the problem with the triangles on the top of it, that one went relatively well. So there's a bit of a disconnect for a chunk of you. All right, let's solve it out, right? Cross products. You don't like fractions, right? So let's get rid of them. And the way we get rid of our fractions is our cross products. 10 times x minus 3. And the first mistake that I saw from a handful of you, and when I say you, it's all my geometries, you didn't distribute, okay? 10 times x. 10x, that's not the issue, but you didn't distribute the 3. 10x minus what? Right. I had a lot of people leave it as 3, okay? Was that you on Friday? Should have been 10x minus what? 30. So that was one of my top mistakes. And then after that, it's just a plain old linear equation, okay? X on both sides. Myself, usually I move the smallest x, but in this case, it's going to be quicker to move than minus 10x, okay? If I subtract the 10x, I get what? Negative 3x, and then divide by negative 3, okay? And here, just based off some of the small things I was seeing, watch your negatives, please. Divide by negative 3, and what do we have? Positive 10, okay? So again, these are simple equations at this time of the game. Now the second one, this is where more of us messed up on. I say messed up, again, it's an easy one to fix. X times x, 6 times 7. We don't have a linear equation. We have ourselves a what? Quadratic, right. How are we going to solve this quadratic? We're going to square root both sides. How many solutions do we typically get? 2. And that's where a good chunk of you forgot that we get typically 2 solutions. So when I pass back your quizzes later on, a lot of you are going to have a plus or minus on there. Okay, so plus or minus, and then simplify the square root of 42. It doesn't tell me any place I'm rounding, so we need to go off to the side and see if you can simplify 42 off to the side. Does 42 go anywhere? No, you can try to take 42 off to the side. 42 unfortunately doesn't go anyplace. 42 does not. I think it was 12 on Friday's quiz. I think it was the square root of 12. And the square root of 12 does simplify down. Some of you did not. Some of you left it as a square root of 12. That's unfortunate because it does simplify down. Square root of 42 does not. And that's what we want as our answer. Okay? I think it was a 12, and 12 is what? Plus or minus 2 root 3 then. That would have been the correct answer. Simplified answer. Okay? So those are small fixes. All right? Those are small fixes. If that's what you think you did on Friday, watch it next time. Okay? That's going to carry us, particularly this one right here, our number 3 here in just a few minutes. That's going to carry us into today, something we call the geometric mean for today. And take a look at our last similar triangle that happens out. And so we'll practice on the difference between, say, the ones that we've done and the ones we're about to do. And then tomorrow, we finally get into the applications of things. Everything we've been talking about really hasn't done any applications. That's more tomorrow. Okay, so let's talk about it. And as like we usually do, let's jump into right here on page, I don't know what page it is, something here. What is that? 500. Okay. Give you a second there. So 500 is where our theorem comes into play at. Okay. And on this page 500, okay, this 2 theorems that happen out. Really, there's only one theorem I want you to kind of remember out. Okay. It's going to be this one right here. There's certain things in math you just got to know. All right. And you're going to leave me here in not too long time, 59 days less. All right. I know some of you are super excited about that. All All right. Um, and there's a second one, and like I said, I get it. There's gonna be some things that we're gonna know, and then it's gonna leave you. It happens. There's definitely certain things though are not gonna fall out. Pythagorean theorem is gonna be one of them. So I want to approach this thing as what's something that you hopefully will not necessarily forget. So on this particular one, let's use the new theorem for today. And the new theorem is going to be, all right, first off, the difference here is we're actually dealing with a right triangle. We haven't dealt with any right triangles at all. What we've dealt with was just any other type of triangle. We haven't looked at any right triangles just yet. And in here, what we have now, we might have called it a couple times. I don't remember if we've had officially yet. But from this, in this right triangle, we got obviously a hypotenuse here, don't we? From the right triangle down to the hypotenuse, we have this perpendicular length. We know it's perpendicular because, well, there's another right angle there. We call that right here, this length right here, we call that the altitude. For those of you that go into physics maybe next year, you'll get a lot more work with that. We call it the altitude. From to be perpendicular from one vertex to the other side. If it's perpendicular to that, we tend to call that the altitude. Or we can also call it the height of the triangle as well. Those kind of get used interchangeably. When that drops down from a right, from that right angle to be perpendicular right here, it does again split up that length of the hypotenuse. Not equally, it could, but it doesn't split it up equally. What it does here is it creates ourselves another proportion. And I'm going to call this x. Okay? I'm going to call this x. All right? And it's going to create what we call the geometric mean. All right? It's the geometric mean. It's going to be this following proportion. Okay? This itty bitty part, which we're going to call AD. Okay? So AD over that altitude is going to be equal to, and I'm just going to give you the equation, give you the proportion. Setting it up is, we're just going to set it up. Okay. Is going to be equal to the other part of the hypotenuse that got split. What's the other part of the hypotenuse? dB. Okay. So on that proportion that we're creating, it's all based off that high altitude, all right, splitting up that hypotenuse. So AD over the altitude is equal to the altitude over the other piece of the hypotenuse. Okay, so this is what that top theorem was saying, the altitude hypotenuse theorem. This is our key for today. Okay. Just like we had worked with last week on a few things, with it not being right triangles and having, say, this side to this side and this piece to that piece. It's the same kind of idea, but now we're having that inner piece right there, okay, the altitude. So with that going, this leads us to our warm-up for today, okay? So this last piece I'm not going to worry about. This is where I was saying earlier, I don't want to worry about this piece because we can use Pythagorean theorem. This is the only new one for today. So where can I use Pythagorean theorem? I'll talk about that in a few minutes. Let's go. Let's use it. I think it's on the next page. Don't care. Let's use it. Okay? So let's use it. I get three variables up there. Of those three variables, which one is representing my altitude then? X is my altitude. Okay, so we can see that right angle shooting straight down to the hypotenuse to be perpendicular. X represents the altitude. So using that little proportion that I just identified for you, set up my proportion. Okay. So what's my proportion going to look like? I know it's been rotated a bit, but what's my proportion going to look like? 5, that piece of the hypotenuse, 5 over what? The altitude. Sorry, yep, the altitude is equal to x again, the altitude over the other piece of the the other piece of the hypotenuse. Okay, that's it. That's going to allow me to solve for x. Go back to your cross products. All right. Cross products we go. 5 times what? 10 is equal to x times x, which gives me x times x. Right. It's going to get you quadratic there, right? Is it perfect? Is it a perfect square? Go do your business. Square root it, right? Square root of 50, take it off to the side. It doesn't tell me anything about rounding, so I always use simplest radical form. You guys know how to simplify these? This is, again, a long time ago from August. It was literally the second thing we did in here. Okay, it's the second day. First day we talked about your perfect squares, and the second day we did these. Square root of 50. Should be able to take it down to the side pretty quickly. Square root of 50, anybody is? 5 root 2, right? Yep. Now, we technically get two solutions. It's positive and negative 5 root 2. But in this case, we have context. What is x representing? The altitude. It's a length, right? Do I keep the negative solution here? No. So I'm not going to keep the negative solution. I'm going to keep the positive solution, right? Now, all of a sudden, we just found a piece of the missing puzzle up there, right? Now we have Pythagorean theorem. That second theorem in there that I talked about, I'm not going to really worry about. We can use Pythagorean theorem. I don't want to throw something additional in there that I for sure know you're not going to necessarily remember. I'll be lucky if you remember this one. Okay. But one thing I know you're going to remember is good old Pythagorean theorem. So we can use Pythagorean theorem to set up z and y. Okay. Let's go find z. Go focus on z. On z, we get ourselves a good old right triangle, don't we? There's Pythagorean theorem up there again, which is your hypotenuse for z, and the 5 and the 5 root 2. I'm sorry, what's the hypotenuse? Z is, right? So this was like day 5 in here when we did Pythagorean theorem. What is it? 5 squared plus what? 5 root 2 squared equals z squared, right? Cool. Go at it. You guys got calculators. Okay. Now, as you're walking with me there through that, what did I do wrong? Call me out on it. What did I do wrong? Thank you. All right. I did this again way back when, and I'll do it again. Call me out on it. The parentheses on that 5 root 2. When I have the opportunity, I'm going to take it because I know we're not 100% there yet. Without doing those parentheses, you're going to get something, again, totally different. Let your calculator do it for you. Okay? 5 root 2 squared, but you better make sure you use those parentheses correctly. And I know we've had more than enough times to practice that out. So what is that? 25 plus 50? 75, right? Square root that thing. Take it off to the side. 75 becomes what? 5 root 3. We got our second variable. Plus or minus. Toss the negative, don't I? Do my last one. Y. What's the y in 10 and the 5? I'm going to use that 5 root 2 again. That 5 root 2 links those two triangles together. So you're going to use that 5 root 2 multiple times there. Okay? So you want to make sure that 5 root 2 is correct the very first time. That 5 root 2 is not correct the first time, well, you're screwed, aren't you? Okay, one more time. In that green triangle line, what's the hypotenuse there? Y. Thank you. So what do I got? 10 squared plus 5 root 2. There's my parentheses. And what? Y squared? And we just did 5 root 2 a second ago, didn't we? So 150, right? And go back to your factor tree, your prime factorization. And somebody. 150. Now you should know 25 is working for you. 25 is going in there. 6 times, right? 5 root 6, correct? Plus or minus, but we don't care about the negative, do we? 5 root 6. So 5 root 6, 5 root 3, and our 5 root 2. The Pythagorean theorem is absolutely coming back into play for the next couple months again. Okay. So for today, it's this new guy we call the geometric mean. That sets the whole thing up, is the geometric mean. And then after that, the Pythagorean theorem supports it. Okay. So let's do another one. That's only one down. Let's flip it. Okay. So on the next one here, not as involved because, well, they don't give you the other two sides asked to find. If we could do that last one, you're pretty solid. So take the next one here, letter A, and set it up for me. Okay. Think about what we just did on that last one. Flip it back if you need to. Go find me the next one there. Okay. Give you a minute. Somebody rattle off your proportion there. What do you got? Okay. And it doesn't matter if you start with 4 or you could have started off with 9, right? Just make sure you're consistent. When you do your cross products, 4 and 9 are multiplying together and x, right? 36 and x squared, right? What's my two solutions? Do I care about the negative? Move it on. Okay. Now this next one, what's my altitude? This time we are asked to find that missing piece in the hypotenuse. So it doesn't matter where that variable is at. Okay. There we go. If you didn't hear her back there, 4 over 8 equals, what did you say, 8 over x, right? Yeah. There you go. 8 is my altitude, so I better see that cross product of 8s. And then you could have said x and then 4. It's not numerator, denominator. That doesn't really matter there. Okay. But then, do we have a quadratic on this one then? No. 4x equals what? 64. This time, again, it's not quadratic, is it? It's linear. 64 divided by 4 is just 16. That's it. Okay. All right. Let's take it down to the next one. What's my altitude on this one? To help me find x, do I? You know, like we did to start off today with, if I look at that triangle, it's a good old right triangle. My hypotenuse is x, the leg is 20, but dang it, I don't know it, do I? We've done it before. If we don't know something, we let it be a variable. Bring in a second variable. Okay? If we knew what that leg was, we can do good old Pythagorean theorem, right? Mm-hmm. So make it a variable. Don't I have now enough information to do a geometric mean again? Mm-hmm. Do it. This is what we just did up above. This is what we did as the very first problem. The only difference is you have to realize I have to put in an additional variable to guide me over to find x. So even if we don't have it marked, we've done this before. So for what? 4 over y, y over 20. Okay. What do we got there? 80 equals y squared. Fortunately, that's not perfect, is it? So we gotta square root that thing. And what does 80 simplify down to? Excuse me, I heard 4 root 5. And what I'm doing in my head too to get that 4 root 5 as well, I realize, you know, it ends in a 0, so I can go with 5. 5 and 16. 5 and 16, 16 is perfect. Square 16 is there's that 4 root 5. Two solutions, don't care about that negative. Now, I got that 4 root 5 locked in, and there's that Pythagorean theorem all over that we tried to use, but we couldn't until I found that leg. You get that leg. Hypotenuse was x, 20 squared, plus 4 root 5. What's going wrong with that 4 root 5 though? Parentheses, thank you. And if you've done this now a couple times here already, you should also know when you do that 4 root 5 squared, what should that 4 root 5 squared take you back to? It better take you back to that 8. It better take you back to right here. If it doesn't, you've squared something wrong there. And again, when you don't put those parentheses, what your calculator is doing, and I know I've done this before multiple times, what your calculator is doing is it's only squaring the 5. That's what your calculator is doing. You want your calculator to do this. You want your calculator to square both the 4 and both the 5. So make sure your calculator is in parentheses to do that. 20 squared is what? 400, right? Plus 80. 480. That's a pretty big fellow there. 480. What do you want to go with on 480? Myself on that 480, it's definitely not perfect, but I would take it off to the side and start off with 480 ends in a 0. I would just start reducing it with your factor tree by 10. No, 480, don't need to find a big number to go in it. It ends in a 0. Start pecking at it with a 10. Okay, so doesn't need to be crazy. 10 and 48. Work with something manageable now. We know 10 is 2 and 5. 48, you guys can work with 48. 48 is 3 and 16. 4 and 4. 2s. Biggest thing I can say with the 480 is better not lose track of any pairs, any of your numbers here. How many pairs did I end up with? A pair of 2s and a pair of 2s. Looks like a 2, 5, and a 3 will get remultiplied together, looks like. So 480, big number. What is that? 2, is that 4? Square root of, 2 times 5 is 10. 10 times 3 is 30. That's a big old one. Finally on that one. If you get that 480, great. That's the new part for today. Simplifying that radical, that's old school. Okay. All right, let's go with the last one there. One more time. Fortunately, on that x and that 2, it's the good old hypotenuse, Pythagorean theorem again. But I don't have that leg, do I? So put in that second variable, put in that additional variable. What's my geometric mean going to look like? What's the proportion going to look like then? 2 to y, y to 6, right? Is that 8? Yep, is that whole deal. Okay, so as Eva just said, 2 to y, y to 6. For the umpteenth time, it's a good old quadratic. Y squared equals 12. 12 equals y squared. What is that? 2 root 3? But again, I don't care about a 2 root or negative 2 root 3. So we toss negative. This one's not as crazy as the last one. So the smaller numbers to work with. And in that right triangle on the left, x squared, nope, I'm sorry, not x squared, 2 squared plus what? 2 root 3 squared equals x squared. Yup. 4 plus 12 is what? 16? Square root of 16 takes me to 4. 2 solutions. Do I care about the negative though? I do not. I get a 4. I get a 2 root 3. Plus, okay, plus, That's it. That's it for today. Okay. That wraps up all of our skills. Tomorrow's application. Okay. All right, that's where I'll shut up and I'll pause it.